Welcome to my channel. In the class 12 relations and functions part 3, we will see the first sum. Show that the relation R in the set R of real numbers defined as R, A, B, A less than or equal to B squared is neither reflexive nor symmetric nor transitive. Let us take the case of reflexive. For reflexive, A should be less than or equal to A squared, need to be proved. For example, take A is equal to 0.5, then A is equal to 0.5 is less than or equal to 0.5 squared is false. So, not reflexive. For symmetric, we have to prove that A less than or equal to B square and B less than or equal to A square is true. Let us take A is equal to 2, B is equal to 1. In this case, substituting two is less than or equal to 1 squared is equal to 1 is false. For B is equal to A squared, B less than or equal to A squared, we have 1 less than or equal to 2 squared is equal to 4 is true. Hence, not symmetric. For transitive, we have to prove if A less than or equal to B squared and B less than or equal to C squared, then A less than or equal to C squared. Let us take A is equal to 2, A is equal to 3, B is equal to minus 2, C is equal to 1. In this case, A less than equal to B squared, that is 3 is less than or equal to 4 is true. B less than or equal to C squared, B is minus 2 is less than or equal to 1 is true. A less than or equal to C squared, that is 3 less than or equal to 1 is false. Hence, it is not transitive. Next sum is check whether the relation R defined in the set 1, 2, 3, 4, 5, 6 as R AB, B is equal to A plus 1 is reflexive, symmetric or transitive. The set R is equal to A plus 1. So 1, 2 is one relation, 2, 3, 3, 4, 4, 5, 5, 6 are in the set. For reflexive, A comma A should be in the set. If you take A is equal to 1, 1 comma 1 should be there, should be in set, which is not true. Hence it is not reflexive. For symmetric, if AB is in R, BA should be in R. For example, one comma 2 belongs to R, but 2 comma 1 does not belong to R. So, not symmetric. For transitive, if A comma B and B comma C are in R, C comma A comma C should be in R. For example, if you take 1 comma 2 and 2 comma 3 are in R. Now 1 comma 3, that is AC, 1 comma 3 is not in R. So not transitive. Next sum is show that relation R in R defined as R is equal to AB, A less than or equal to B is reflexive, symmetric and transitive. For reflexive, A comma A should be in R if A is equal to 1, B is less than or equal to 1 is true. So it is reflexive. For symmetric, if A is less than or equal to B, then B is less than or equal to A is also true. Take for example, A is equal to 2, B is equal to 3. Then A less than or equal to B, that is 2 less than or equal to 3 is true. But B less than or equal to A, that is 3 less than or equal to 2 is false. So, not symmetric. For transitive, A is less than B and B is less than C, then A should be less than C. That is, for transitive, if A is less than or equal to B and B is less than or equal to C, then A is less than or equal to C. For example, take A is equal to 2, B is equal to 3, C is equal to 4. A less than or equal to B, that is 2 less than or equal to 3 is true. B less than or equal to C, that is 3 less than or equal to 4 is true. A less than or equal to C, that is 2 less than or equal to 4 is also true. Hence it is transitive. Thank you very much. We hope you understood the solution to the problem. If you have any doubt, put it in the comment box. We'll come up with a doubt clearing video. In the next series, class 12 relations and functions part 4, we'll see the further sums. Thank you very much.